Okay, let's dive into this. Welcome to the Explainer. Today, we're unpacking the absolutely fascinating hidden chemistry that surrounds us every single day. We often walk through our lives interacting with objects, breathing the air, eating our food, totally unaware of the magnificent, microscopic architecture that makes the whole shebang possible. Well, today we are making the invisible visible. Let's look at the true building blocks of our everyday life.
So think about this for a second. What links a simple glass of water, a deep breath of fresh air, and that sharp, refreshing fizz in your favorite soda? On the surface, they seem completely different, right? One's a liquid you drink, one's a gas you literally need to survive, and the other is just a tiny bubble popping on your tongue. But they share a profound connection. These incredibly common, tangible things are all defined by invisible building blocks. And by understanding these tiny structures, we unlock the secrets of, well, everything around us.
Here is our roadmap for today. We'll start with the chemistry all around us, then move to reading chemical formulas, followed by visualizing invisible shapes, and finally, the master organizer. Starting off with Section 1, the chemistry all around us, from visible to invisible. Before we can really talk about specific molecules, we need to understand how scientists actually label them. They use something called a chemical formula. Simply put, a chemical formula is just a short way to write a molecule using element symbols and numbers. The numbers tell you exactly how many of each atom are in that specific molecule. Think of it as a clever shorthand code, a real game changer that saves scientists from having to draw out complex pictures every single time they want to describe a substance.
And this brilliantly illustrates the whole concept. Think of it like Legos. A single brick, that's your atom, the absolute smallest unit. Now, if you take two Lego bricks and snap them together, boom, you've created a molecule. Atoms combine to form molecules. Finally, if you have a massive pile of identical red Lego bricks, that represents an element because they're all the exact same kind of atom. This distinction right here is absolutely crucial. It's the foundation of everything we're exploring today.
Bringing this back to our opening question, let's look at those everyday molecules in action. First up, H2O. Every single drop of water, whether it's in a massive lake or just a tiny raindrop, is made of trillions of these tiny H2O molecules. Next, when you breathe in, billions of O2 molecules rush into your lungs. Oxygen atoms actually travel in pairs to keep us alive. And when you breathe out, you release CO2, or carbon dioxide. That's the exact same molecule that gives soda its fizz by escaping as gas bubbles. And amazingly, plants use that very same carbon dioxide from the air to make their food through photosynthesis. The molecule you exhale is literally plant food. It's just a perfect continuous cycle. Moving right along to Section 2, reading chemical formulas, the master recipe book. Now, what's really interesting about this concept is how it all translates. You can actually think of reading a chemical formula exactly like reading a baking recipe. The letters in the formula tell you which atoms are in the molecule. They're your ingredients. And the small numbers next to those letters, they tell you exactly how many of each atom to use. Oh, and here's a little insider secret for reading the universe's recipes. If there is no number written after a symbol, it simply means there's just one of that specific atom. So no number equals exactly one. Easy? Let's put this recipe translation guide into practice. Take a look at H2O, which is water, compared to O2, oxygen gas. For water, the H has a 2, so that's 2 hydrogen atoms, and the O has no number, meaning 1 oxygen atom. But oxygen gas is just O2, simply 2 oxygen atoms bonded together. The same logic applies everywhere. CO2, carbon dioxide, is 1 carbon atom plus 2 oxygen atoms. And once you know this secret, you can read anything in a snap. NaCl, which is everyday table salt, is exactly 1 sodium atom and 1 chlorine atom. N2, nitrogen gas, is just 2 nitrogen atoms. It truly is as simple as following a recipe.
All right, on to Section 3, visualizing invisible shapes, building models.
So these recipes don't just sit on paper. They physically take up space in the real world. To visualize this, imagine building models out of gumdrops connected by toothpicks. When you build them, you see that molecules have very distinct physical 3D shapes. If you use a red gumdrop for oxygen and 2 white ones for hydrogen, you'll actually find that a real water molecule, H2O, is bent. The hydrogens aren't just in a straight line. Oxygen gas, O2, uses 2 toothpicks side by side to represent a double bond. Carbon dioxide, CO2, is straight as a stick. And nitrogen gas, N2, uses 3 toothpicks side by side. That incredibly strong triple bond is exactly why nitrogen behaves the way it does in our atmosphere. The numbers dictate the ingredients, and the bonds dictate the actual physical shape. Now, here is a conceptual check that is absolutely vital to understand. The identity of a substance is tied entirely to its unbroken molecule. A whole, intact H2O molecule behaves like water. But if you were to break that molecule apart, snapping the toothpicks and ripping the gumdrops away, what happens? Well, you don't just have smaller pieces of water. No way. You are left with 2 individual hydrogen atoms and 1 individual oxygen atom. It's no longer water. Breaking a molecule destroys its very identity completely.
Which brings us to Section 4, the master organizer, solving the elemental puzzle. Let's move to this and see how it all builds together.
We've looked at single atoms and individual molecules, but how on earth do we organize the entire universe of elements? Back in 1869, scientists knew about roughly 60 elements, but it was just a chaotic, unorganized list. Enter a Russian chemist named Dmitry Mendeleev. He approached this like the ultimate scientific detective story. First, he wrote the properties of the known elements on cards. Then, as he arranged them by weight, he spotted something incredible. Their properties repeated in a regular pattern. But the puzzle was incomplete. Mendeleev realized there were missing pieces that no one on Earth had even found yet. So he left intentional gaps in his arrangement. And Mendeleev did something incredibly bold here. He predicted the specific properties of those missing elements before they were ever found. He didn't just leave empty spaces. He told the world exactly what those undiscovered elements would look and act like. And when scientists years later finally discovered them, they found that Mendeleev's predictions hit the nail on the head. They were exactly right. This was literally a mic drop moment in chemistry history. It proved that his periodic table wasn't just a simple list, it was a predictive, fundamental tool of science.
So the crucial point is, chemistry isn't just something that happens in a lab wearing a white coat. It is the fundamental fabric of your reality. Look around the room you're sitting in right now. The air you're breathing is filled with billions of O2 molecules. The water in your glass is teeming with trillions of bent H2O shapes. Every single object is a collection of invisible recipes, snapped together like Lego bricks, just waiting to be understood. So what invisible recipes and undiscovered chemical puzzles are floating right in front of your eyes at this very moment? Thank you for exploring the building blocks of everyday life with me. Keep wondering, and keep looking closer.